the binomial expansion, also called binomial theorem, we're going to expand this. Now you could write it out 4 times to expand it, but that'd be a pain. So what we're going to do is, it uses, you focus on this, first of all, and you put 4, because it's the 4th power, and your combinations from 4, 0, all the way to 4, 4. Oops, I said 4, 4, so I wrote 4, 3, 4. Okay, so I have 4 combination from 0 all the way to 4. That's your first step. Your next step is to take this term and you start with the 4th power, but first let's write that term. Just got to keep writing it. Kind of a long process, but it's a to the 3rd, and you're going to take that to the 4th power. Then you're going to do the 3rd, the 2nd, the 1st, and the 0. Okay. Here we went from the 0 to the 4th. Now we go from 4th to the 0. And the last one, you take the negative 3b. So we got to go negative 3b. Kind of, again, takes a while to write it all. And then what power do we start with? Not the 4th, but here we start with the 0 power and work your way down to the 4th. Now again, these powers should always add up to that. So that's the 4th power. These should add up to 4, 4, 4, 4, 4. Now we just got to find this, simplify it. Now, the easy way to find this right here is to use Pascal's triangle. Now, Pascal's triangle. How it works is you start with a 1, then you put 2 more 1s, then you put 1s all along the edges. Now, what goes right here between 1 and 1? Well, what's 1 plus 1? When you add them, you get 2. What goes here between 1 and 2? 1 plus 2 is 3. 2 plus 1 is 3. Put 1s on the edges. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Now, do we have our 4? Is that the exponent we're dealing with? So basically the first thing you do, once you have this, you could keep going, but that's as far as we need to go. You look at this row. That row tells you the combination row. Then you look across from that, and those are your combinations. That's 4C0, 4C1, 4C2, 4C3, 4C4. It's a very quick way to find all your combinations. You could also find each one by one. This is just kind of easier. So, from that, what is 4C0? Well, it's 1. What is 4C1? Well, it's 4. 4C2 is 6. 4C3 is 4. And 4C4 is 1. So we found our combinations. Next, a to the third to the 12th to the 4th. A to the third to the 4th, you multiply those powers, so it becomes a to the 12th. A to the third to the 3rd, you multiply the powers, so it's a to the 9th. A to the 3rd squared would be a to the 6th. And do you see a pattern? See how it decreases by 3? What do you think this is going to be? Just 3rd. And anything to the 0 you have to remember is 1. The next piece, dealing with the red stuff, kind of keeping the colors together. Okay, anything to the 0 is what? 1. What's negative 3b to the 1st? Oh, it's just negative 3b. What's negative 3b squared, meaning negative 3 times negative 3 is positive 9. And what's b times b? B squared. Okay, what's negative 3 to the 3rd? Well, negative 3 times negative 3 times negative 3 is negative 27, and b times b is b to the third. Do you see a pattern? Aren't we just multiplying by negative 3 each time? So what's negative 27 times negative 3? It's actually going to be positive 81, and aren't we just adding 1 to the power? It's all about patterns on this. It gets a lot quicker if you just look at the pattern. Lastly, actually not last, last on this section is you multiply straight across. So you got here is a to the 12th. When you multiply straight across here, first thing you do is focus on the numbers. What's 4 times negative 3? Hopefully you see it's negative 12. Then you take the variables. That'd be int and b. Next, focus on the 6 and the 9. 6 times 9 is 54. And then you have a to the 6th and b squared. Ooh, 4 times negative 27 will be negative 108. And then you have a to the third, b to the third. And the last one's pretty simple because it's multiplied by 1. Everything is. Do any of these combine? No. Do you see patterns to check yourself? Are A's going down evenly? Are B's changing regularly? You kind of see patterns, making sure everything's correct. The numbers you just got to be careful with. It's easy to mess up the numbers. Anywho, your answer, the first piece, then you have the second piece, then you have the third piece, then the fourth piece, and then the last piece. Now, it might have been quicker for some people who are really good at FOIL to FOIL that, make 4 of them and do a whole bunch of foiling. But this, I think, is a little bit more organized and easier to keep from making mistakes. And this is the way you have to do it. Okay. There are actually 2 questions on this benchmark. Don't get scared. The second question is, you have this, and it wants the third term, but it wants the coefficient. What's the coefficient of the third term here? Well, this is the third term, right? The coefficient's the number in front. It's 54. The coefficient of the fourth term is negative 108. The coefficient of the fifth term is 81. So if we want the third term, we basically got to go 3 spots down. So our power here is 6. So we're going to have 6C0, 6C1, and 6C2. Do you understand if we're doing the third term, we just go 3 down? We don't have to go all the way down. Got it? It tells you we're only focusing on one piece. Okay, our first piece is x. And then what do we start with, 6 or 0? Look over here, you start with the power, so you start with 6. Work your way down. And then for the next piece, you're going to take negative 3. And which power do you start with? You start with the 0. Now, real quick, does 4 plus 2 equal 6? Does 5 plus 1 equal 6? 6 plus 0 equals 6. Are we good? Now, which one do we care about? We want the third term. So can't we just figure this one out real quick? And that's all it's asking for? Now, could I continue this to find 6C2? Or could I just do 6C2 going, okay, that's 6 times 5 over 2 times 1. Is that probably quicker? That would be 15. So don't we now have 15 x to the 4th, and what's negative 3 squared? Is that 9? So is my coefficient 15? No. Isn't it 15 times 9? So 9 times 15. 9 times 5 is 45. 9 times 1 is 9, plus 4 is 13. So my answer is 135x to the fourth. So what's my coefficient? What's the number in front of the x to the fourth? 135. Do you see how much quicker these problems are? They just ask for a specific piece. They ask you, okay, think about the problem, start it off, but I want the coefficient of a particular part of it. Here you have to do the whole thing. Here you have to just kind of fine-tune and find a specific piece.